Hello and hi everybody. So in this video, you're going to learn on how to draw free body diagram. Before we start drawing the free body diagram, let's ask question, what is FBD? Free body diagram or FBD is a force diagram that represents all the forces acting upon an object. FBD has arrows and each one of the arrows represent specific type of forces. Okay, there are 4 crucial steps that you need to follow in order to draw your FBD in any given situation. Okay, so step number 1, when you are given a question, you have to identify all the forces acting upon an object. Okay, step number 2, you have to draw coordinate system. What means by that? You have to draw X and Y axis. Okay, and then step number 3, you have to draw or represent the object using a dot. And the dot must be placed at the origin of the coordinate axis. Okay? And the last step is you have to draw the vectors using arrow representing each of the identified forces. So for example, if you have one situation and there are 3 forces acting upon an object, therefore you have to draw 3 vectors and make sure you label all the vectors. And then the crucial part is you have to make sure, okay, ensure your arrow must be always outward from the dot. Okay, so this is very compulsory, must be always outward. Okay, let's start with first situation. Okay, in this situation, okay, you can see that we have a slat. Okay, there. So slat, we treat it as the object for this situation. Okay, and then we place the slat on the horizontal smooth surface. So what means here is it gives us the idea that there is no frictional force acting upon the slat. Okay, so for example, in the question, it mentioned clearly that the surface is smooth. So actually, it tells us that no friction. Okay? Okay, so let's identify all the forces acting upon the slat. Okay, the easiest force to get identified is weight. Why? Because everything in this world got weight. Okay, the second force is, since you could see clearly that the slat has contact with the smooth surface, therefore it has normal force. Okay, and then since the arrow here, okay, tell us that the slat is being pulled, means that there is external force for this case. So we have 3 forces to be drawn on the free body diagram. Okay, the next step is you have to draw X and Y axis. So I already draw like I do here. Okay, and then the next step, just proceed. Represent your slide or represent your object as a dot, and make sure you put the dot at the origins of X and Y axis. So this is the dot. Okay, now time to draw the arrow. Okay. Okay, so we got weight. First force that we have is weight. In any situation, in any problem, weight must be always pointing downward. Okay. So make the arrow, and then don't forget to label your weight as vector W. And then second, we have normal force. So normal force must be always 90 degree to the surface or always perpendicular to the surface. So like we mentioned, this is the surface. So 90 degree to the surface is the arrow should be pointed upward here. Okay, so just copy the arrow on your free body diagram. Okay. So this is your normal. Don't forget to label with capital N, vector capital N. And then the last one is your external force. I just label with capital P. Follow the question. Vector capital P. Okay, some students ask, Madam, do we need to draw the angle 30 degree? That's not necessary. Okay, but if you do, it's not wrong. Okay, your mark will not be deducted. Okay, so we're done for the first case. Okay, we move to the next case. Okay, for this case, we have a special case or a bit different, which is we have inclined plane. Okay, but here it mentioned that the inclined plane is rough. So actually it tells us something. Okay, rough here is the key words that tell us actually we have frictional force. Okay, and in this case we have the block as the object. Okay, and then the block is at rest. Okay, start with step number 1. Identify all the forces acting upon the block. So, the easiest force to be identified is weight. And then, since you could see clearly that the block is in contact with the inclined plane, means it has normal force. Okay, and then since it mentioned that the surface is rough, so like I said before, it has frictional force, but then since the block is at rest, therefore we have static frictional force. Okay, we done identified all the forces acting on the block, and then proceed to the next step. You have to draw X and Y axis, but then since the block is placed on the inclined plane, therefore your Y and X axis should be drawn a bit tilted. Okay, like I drawn on the screen here. Okay, this is my Y, and this one is my X. So I put it a bit tilted. Okay, to help me draw the free body diagram a bit easier. Okay, and then put the dot to represent the block at the origin. And then we are going to draw weight. And in any situation, like I mentioned a few times, weight should be always pointing downward. So this is our weight, the arrow must be downward, and don't forget to label your W. And second, you want to draw your normal force. Okay, since this is the surface, okay, to draw normal force, it must be 90 degrees. So this is the direction, 90 degree or perpendicular to the surface. So just copy your arrow here. So actually, your normal is aligned along the y-axis. Okay, that's your normal. And the last one is static frictional force. So how we gonna draw the frictional force for this case? Okay, so this is the tendency of the object or block to move. So this is the direction, the tendency of for the block to move. So the frictional force or static frictional force must be drawn in the direction opposite with the frictional force. So your Fs should be in this direction. Okay, so we just copy. So actually the arrow for static frictional force is here. Don't forget to label vector F subscript S. So we're done drawing for the case number 2. And then we proceed to the next case. Okay, we have a bit different case, which is we have hanging object. In this case, actually we have two free body diagram need to be drawn. Okay, first one is actually free body diagram for the node here. This is, we call it the node junction, which joining all the string. That's the node. Okay, and then the second free body diagram that you have to draw is for the block. So this is block. And then your block are tied with 3 different strings. So this is, okay, this one is string 1. Oh, sorry. This one is string 2. And this one is string 3. Okay. The block are tied with 3 different strings. So we're gonna have a different value of tension. So means here you have to label your tension with different level. Okay. Okay, let's identify the force that acting on the node. Okay, look at here. The node just tied with the string. Therefore, we just have tension. We just have tension force. Okay, but for the block, since the block got mass, therefore it gonna have weight. And also since it is tied to by a string, therefore it has also tension. Okay, now the time to draw the free body diagram. First for the node. Okay, so draw the x and y axis and then put the dot to represent your node, and then draw the tension, draw all the tension that acting upon the node. So we got here is first T1. So we just label as vector T subscript 1, and then we have T subscript 2, and then the last one is vector T subscript 3. Okay, actually to draw vector for tension, more students got the problem. Okay, actually the key things to draw the tension is first, okay, for tension, First, your arrow must be along the string. That's the first thing. Second, your arrow must be away from your object. Okay. So first, arrow must be along the string, and then the second is the arrow must be away from your object. So for our first free body diagram, the node is our object. Therefore, the tension must be along the string. So this is our string, but then it should be pointed away from the node. So for this one, that's why the direction of T1 is in this way, and T2 is along the string but then away from the node, so in this way. And T3, okay, so this is your object, so T3 would be pointed downward. So just copy all the arrows on the free body diagram. That's so easy. Okay. Okay, so moving on to the free body diagram for the block. Okay. Okay, don't forget to put your dot on the at the origin. Okay, we have weight which is always pointing downward. Okay, so the arrow, and don't forget to label your W. And then now time to draw the T3. Okay, so this time your T3 is not pointing downward. Why? Because this time, okay, but because this time your object is blocked. So this is your string, but then for the second condition, it said that, okay, the arrow must be away. So if it is away from the object, means T3 this time should be pointing upward. Okay, so this is your T3. Okay. Okay, so we done for case number 3. Okay, moving on to the last case, which we have frictionless pulley. And then for this case, we have two objects, M1 and also M2. Okay, so we have two free body diagram to be drawn. Okay, let's identify the force acting upon the object first. For M1, definitely we have weight. Okay, and then also tension, since it is tied by a string. Okay, for M2, since you see here, the block is in contact with the surface, so means that it has normal force. And second, it has tension since it is tight. And the easiest force to be identified is weight. And then you can see from the blue arrow here, okay, the M2 is being pulled by vector F or external force. So we have external force. And the last one, okay, since it gives us the coefficient of friction, therefore it tells us that there is frictional force. But then since it labeled here, the block got acceleration, so means M1 and M2 are in motion. So this is the directions of motion. Therefore, the kinetic frictional force should be in the direction opposing the motion. So it should be in this way. Okay. So we have kinetic frictional force. Okay, let's draw our free body diagram. Draw the free x and y axis, put the dot. Okay, and then we start with the mass number 1. So we have weight pointing, always pointing downward, but then I label with W subscript 1 to differentiate between M1 and M2. And then we have tension. Okay, we have tension which pointed upward. Why? Because this is our object, and this is along the string, and then it should be pointing away from M1. So I just label tension simply with capital T. Why? Because M1 and M2 tied with the same string. That's why we just label with capital T. Okay. Okay. Free body diagram for mass 2. We have normal force. Okay, put the dot first. And then we have normal pointed upward. Okay, and then we have weight subscript 2. And then we have external force. Okay, and then we have tension. And then the last one we have F subscript K to represent the kinetic static friction. Okay, so these are the free body diagram for case number 4. So what I mentioned before, since you could see here, T here and T here, I just label with same T because of the same rope. Okay, so that's all for this video. I hope this will help you guys. So thank you.